Hey, so I have a problem on the board here today, and I want to do this with a Weierstrass substitution. In the previous video, I did a first example, an easier example on the Weierstrass substitution, and I showed how we derive the formulas to the right, not the left, the right side. We start with the substitution t equals tan of x over 2, and from that we can derive all these formulas below. And if you don't understand where that's coming from, you can go back and check out the first video and that will explain how we derive those. But what we'll do here, since we have those values, we're going to go and we're going to substitute those in to our given integral. So first, what I'm going to do is I'm going to pull the 3 out. We'll have the 3 in front, and then we'll do our dx, which will be this value. So we're going to substitute in 2 dt over 1 plus t squared. Then next we will have, let's just do like level 1 on top, and then we'll substitute for 5. And I'm going to write 5 a special way. We're going to write that as 1 plus t squared over 1 plus t squared. We have 5 on the, this is 1, right? So that's the way we're going to write 5. And then for cosine, we're going to substitute in from here, 1 minus t squared over 1 plus t squared. Wow, terrible too. Okay. 1 plus t squared. Okay. And then good thing about this is we have a lot of convenient cancellation because we have a 1 plus t squared here, and that's going to cancel that and cancel that and cancel that. Then we'll rewrite what we have. And I'll do is I'll bring this 2 to the outside. So we're going to end up with 6 dt. And then we're going to distribute here, and this, well, there's nothing to distribute here. So we're going to have 5 plus 5t squared plus 1 minus t squared. Okay, good. Then I'll switch colors. Then I'm just going to simplify, combine like terms. So we're going to have 6 plus 4t squared. And what I'm going to do, I'm just going to pull a 4 out of here. We'll factor a 4 out. And we're going to have 6 over 4. And our integral is going to be t squared plus 3 halves is what we'll have here. What I'm going to do is I'm going to rewrite this as square root of 3 halves squared, just because then we can use our inverse tan formula. So then next, let's just simplify a little bit. So 6/4, we're going to rewrite that as 3 halves. Then we have a formula. Let me just, I'll call it to the side here, and we'll just say, so the integral of, it's kind of a common formula, t squared plus a squared, we'll say. This integral is equal to 1 over a tan inverse of t over a. Okay, and you'll notice that here we have the integral in that form. It's just that our a is square root of 3 over 2. So then, let me back up for a second. Let me erase this. So we established a is, it's changing, okay. We've established a is the square root of 3 halves. And we'll use this formula here. So what we're going to end up with is 1 over a, so let's see, yeah. So 1 over a being square root of 3 over 2, and inverse of t over square root of 3 over 2. And okay, now coming down here, we just need to rewrite this. So we'll be down here. What I'm going to do, because we have this fraction in the denominator, I'm going to flip it around. So we can rewrite this as 3 square root of 2 square root of 3 tan inverse. And we'll do the same thing here. And write this like this. And then I think, can I do anything else? Yeah, let's multiply this by square root of 3 over square root of 3, and we'll do the same here. Okay, so what we're left with is 3 square root of 6 over 6 tan inverse square root of 6t over 3. And then finally what I'm going to do, I'll write this as square root of 6 over 2 tan inverse square root of 6 over 3, but we will remember that our t is actually tan of x over 2. We can write this as tan x over 2. A little messy. Extend that, plus c, and then we're done. So that's it. That's all that you need to do for a Weierstrass substitution. It can get a little messy with the simplification, but it's better than it's a hard integral to solve without it. So this is a pretty good technique. I will, in the description, I'll post a link to my video, my previous video, first one in the series, and then also to my quiz on the Weierstrass substitution. Thanks, I'll stop it there.